Good afternoon, friends. So, in this lecture, we are going to start with the kinetic energy of a rigid body with the 1 point fix. We are going to find out, right? That means we have to find out kinetic energy of a rigid body. In the last lecture, we have seen what is an angular momentum for the rigid body if 1 point is fixed, and before that, we have seen the what are Eulerian angles, that is uh, phi, theta, and psi. And after that, we have found their matrix of rotation. We have multiplied them b into c into d, and that the matrix A which we have obtained is a matrix of rotation, obtained transformation matrix from x to x dash. The transformation is obtained in a step by step procedure. The first one is rotation through an angle phi, then through theta, then through psi, and after that we have seen what is an angular momentum if 1 point of the rigid body is fixed out, and we have found what is Lx, Ly, and Lz, and we have written this equation in the form of Lx, L is equals to I into omega. If you remember this equation, we have found L is equals to I omega, where I is a 3 cross 3 matrix, and W is with Wx, Wy, Wz, L is Lx, Ly, and Lz. Okay. Now let us go for the next point, that is kinetic energy of a rigid body with 1 point fixed. Okay, what is the question? Find the kinetic energy of a rigid body rotating about a fixed point of a body. Okay, that means suppose we are having this is what a rigid body, and if 1 point of the rigid body is fixed out, then as I told you that if 1 point of the rigid body is fixed, then there is no translation motion, only there will be a rotational motion. Rotating about a fixed point of the body, in the moment of inertia of a body and the product of inertia of a body related to the set of axes of the body are known. That means we are provided with the moment of inertia, that is I. We are provided with moment of inertia of a body, and the product of inertia of a body related to the set of axes to the fixed point are known. Okay, we are provided with moment of inertia and all. Since we are having one rigid body which consisting of mass mi, that means m1, m2, m3, and so on, and let their position vectors be denoted by ri, and mi is a mass of a body of a mass of ith particle, ri is a position vector of ith particle of a rigid body. Since 1 point of the rigid body is fixed out, we have translation motion is absent, and the body rotates about a fixed axis passing through the point with an angular velocity omega. That may be here the angular velocity is omega. And how we write this relation between the linear velocity and angular velocity, that we have studied in the last lecture, that is angular velocity cross product with position vector. If T is a kinetic energy, how we write the kinetic energy? T is equals to 1 upon 2. So kinetic energy T is equals to kinetic energy T is summation over I. Since we are considering n number of particles, summation I runs from 1 to n, 1 upon 2 mi vi square, which is equal to, now this vi I can split into two forms, that is summation over I as it is 1 upon 2 mi into vi dot product with vi. Now for 1 vi, we will replace this formula. Okay, that is the relation between angular velocity and linear velocity. And then we will proceed. This is summation over I 1 upon 2 mi into vi as it is into w cross ri. Right. Now we know that what is the idea of cross product A dot B cross C. This A dot B cross C is nothing but your box product. We can write it as ABC, which is equals to BCA, which is equals to CAB. Okay, which is nothing but A dot B cross C. I can write it as B dot C cross A and C dot A cross B. So considering this as A, this will be C. And hence we get it is equal to summation over I 1 upon 2 mi into, which we can write it as W cross W into Ri cross Vi with the help of this property. Now you have to verify what is A, B, C and you have to check this. And after that, this is what's 1 upon 2 outside of the summation over I. This mass I can multiply inside this W as it is, W cross Ri into Mi into Vi. Right? Why I am going to multiply mass inside? So that mass into velocity is nothing but your momentum. And hence we get this 1 upon 2 outside summation over I W cross sorry W dot W dot Ri cross mass into velocity is nothing but your linear momentum, that is Pi. Now I hope everyone remember the first lecture, the basic lecture of classical mechanics, in which I have written what is a formula for Ri cross Pi. Ri cross Pi is nothing but your angular momentum, and hence we get this equation, that is kinetic energy T is equals to, now this summation we can take here and then combinedly we can have this as value of L. Then kinetic energy T is equals to 1 upon 2 W into L. We can write this as 1 upon 2 omega, that is angular velocity, summation over I cross Pi. The value of this term we have got it as capital L, which is an angular moment. And hence, say this is our equation 1, which we have obtained. Kinetic energy T is equals to 1 upon 2 angular velocity into angular momentum. Here you can write this L is equals to summation over Ri cross Pi, that is angular momentum. What is linear momentum? P is equals to mass into velocity. And what is L? L is a summation of all the Li, that is angular momentum acting on each and every particle. Now we know that what we know that L is equal to I omega from the last theorem. And what are the equations of Lx, Ly we have, that we will write first. Since we have to evaluate this equation, what is our equation 1? Is equal to 1 upon 2 L into omega. And here we know what is the value of L. L is nothing but I into omega. So after evaluating this, we will put again back in our equation 1 and then we will solve it. is Lx, it is Wx Ixx plus Wy Ixy plus Wz Ixz Wx Iyx plus Wy Iyy plus Wz Iyz, and Lz is equals to Wx Izx plus Wy Izy plus Wz Izz. Now let us evaluate our equation 1. What is our equation 1? We have obtained is T is equal to 1 upon 2 W into L. Now let us substitute the value of W and L. W is with Wxi plus Wyj plus Wz into k, multiplied with this is Lxi plus Lyj plus Lzk. After multiplying this, we get it is T is equals to 1 upon 2. As we know that what is the multiplication of this, we have to evaluate with the help of a dot product. I dot I is 1, I dot j will be 0. Because since I and j are the unit vector in the direction of x and y axis, and what is an angle between x and y axis? It is 90 degree. So cos 90 is 0, and hence we get the resultant of this dot product as Wx Lx plus Wy Ly plus Wz Lz. Now we know what is Lx, Ly, Lz. Just now here we have written. These are Lx, Ly and Lz. Now here we have to use this Lx, Ly, Lz. And after using this Lx, Ly, Lz here, then we get 1 upon 2 Wx multiplied with Lx. Okay. Wy multiplied by Ly, and after multiplying this, I can write this equation as Wx square Ixx plus Wx Wy Ixy Wx Wz Ixz. This is what the first term after multiplying Wx with Lx. Plus what is the next term after multiplication of Wy with Ly? plus wx wy iyx plus wy square iyy plus wy wz iyz. The next are we have to multiply wz with lz. It will be wx wz izx plus wy wz izy plus wz square izz. Okay, this is what the equation we have obtained after substituting the value of Lx, Ly, Lz and Wx in our equation 1 and multiplying, which is what the required value of a kinetic energy. Okay, this is what a very big equation we can get for kinetic energy of a rigid body. In particular, if suppose the body is rotating about a z-axis. If the body is rotating about a z-axis, that means that the things which we have seen in the last lecture, that means if suppose z-axis is fixed and there is a rotation of x and y, just like that, if a body is rotating about a z-axis with angular velocity omega, okay, if rotating about a z-axis, obviously what will be the resultant? Wx is 0, Wy will be 0, and what will be Wz? Wz is nothing but your W, that is angular velocity. So resultant, what you get? Wx, Wy, wherever you have Wx and Wy, you will get 0. And then the above equation becomes T is equals to 1 upon 2 Wz square into Izz, which we can write in general as T is equals to 1 upon 2 omega square into I. And which is what? The required equation for kinetic energy of a rigid body with one point fixed, which we have obtained in terms of moment of inertia and angular velocity. Okay, what we have done for this, initially we have started with rigid body with one point fixed. If one point of the rigid body is fixed, consisting of n particle with mass mi is a mass of the ith particle, ri is a position vector of ith particle. If one point is fixed, obviously this body will rotate about some fixed axis with angular velocity omega. And we know the relation between linear velocity and angular velocity, which is Vi is equal to W cross Ri. And after that, we have to use a formula for kinetic energy, which is summation over I 1 upon 2 mi into Vi square. Why we have used a summation here? Because we have a system of n particles. And after that, simply we have to split that Vi and substitute the value of a Vi, which is in terms of angular velocity, and then use the box product formula A, B, C. You have to verify what is A, B, and C. And simply this box product, we can write it as W dot Ri cross Vi. And after that, this Mi, that is mass, we can multiply inside. So that mass into velocity is a linear momentum, and after solving this we get it is in the form of L is equal to, what is the formula for angular momentum is Ri cross Pi, and this is the value of this Ri cross Pi is Li, this summation over I as it is, that is summation over Li is nothing but your angular momentum acting on whole body. Li is angular momentum acting on ith particle of this system. And hence which above equation becomes T is equal to 1 upon 2 L into omega. Now we have to substitute the value of L and omega. Before substituting that, whatever we have obtained in the last lecture, we have to substitute the value of Lx, Ly and Lz, and then multiplying this, we get up the equation T is equal to 1 upon 2 omega x into Lx plus omega y into Ly plus omega z into Lz. And then we have to multiply omega x with Lx. And after multiplying all these, we get this big equation, which is the equation of kinetic energy of a rigid body with one point fixed. Now, if suppose whatever the cases we have seen, that is if rotation is about x-axis or y-axis or z-axis, in particular, if we consider rotation about a z-axis, then the angular momentum about y and z will be 0, y and x will be 0, and the angular momentum about z-axis is nothing but your omega, and hence we get this equation. Or in another way, you can consider the body is rotating about a y-axis. Instead of considering the body is rotating about a z-axis, you can consider the body is rotating about a y-axis also. So here we complete this kinetic energy of a rigid body. In the next lecture, we are going to see the what is a relation between body set of x's and space set of x's. That is, we want to prove that d by dt of fixed set of x's is equals to d by dt of rotational plus omega cross some quantity. That quantity we will determine later on. But up to now, you have to remember this that in the next lecture, we are going to prove this theorem. D by dt of space set of x's is equals to d by dt of. Here, the same quantity will be there. Whatever d by dt we are writing. यहाँ पे जो आएगा वो सेम क्वांटिटी डी बाई डी टी के फॉर्म में है. Set of x's, these are body set of x's, w cross the same quantity. And we have to justify the answer for this. This theorem is very big, so that's why we will take it in the next lecture. Thank you.